Okay, this time we are going to throw something vertically on a cliff. So we initially have a position. First highlight has 40.0 meter, which is a vertical displacement. The next emphasis is an initial speed of 12.0 meter per second, vertically upward. Then the situation complicates a bit. It reaches a maximum, then it will fall all the way to the ground below. The question eventually asks about the final velocity of the coin just before it hits the ground. That's the scenario. I'm gonna do something a little different this time. I'm gonna divide the space in half. On the left side, I'm gonna consider the scenario halfway, which means straight up travel. Right side, I'm gonna focus on falling scenario. As usual, visualization first. I indicated the initial position as height, 40 meter. Then I decided initial velocity as 12 meter per second, final velocity as 0 because we are interested in our maximum height, then acceleration as negative 9.81. Then I put my maximum height as question mark. Some of you guys may wonder, why Genius try to find the maximum height even though the question does not ask anything about it? Is because if you think about the final velocity right before the ground hit, consider that as if someone dropped a coin at the maximum height that we don't know yet. Then we will get a free fall situation. I understand it's tricky. If that explanation is tough, just consider a free dropping a coin situation from a maximum height that is even further higher up than 40 meter. Then we will get whatever the final velocity right before it hit the ground. Because we don't have any given time, we theoretically have only one formula that we can use, which is shown on the board. Since we are trying to find the maximum height the coin travel, final velocity is 0, thus we cancel out and we are gonna isolate things around. I put 0 on the left side, and instead of delta D, I put H max. I moved VI square to the left side by subtracting as first, and divided by 2 and A, which is the given variable we can simply substitute. Thus, we will have H max isolated. Don't forget unit analysis. We found that second square cancel out and only single meter left on the top. Plus, sign, negative and negative cancel each other to be positive. Once you substitute, you will get 7.339 blah 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 meter. Please do not round it up. What I'm going to do, and this is tricky, is consider that height plus 40 meter that you initially begin with as the total displacement that the coin travel for the right side scenario, aka a free fall scenario. And if you wonder, that's right. We did all the left side calculation to find out how far the coin traveled from the maximum height all the way to the ground. Just like before, write down key clue. Initial velocity is 0 this time because it's a free fall situation. Acceleration negative 9.81 meter per second square. And final velocity is what we try to find. I'm going to use the same kinetic equation as previous one because time is simply not given. I canceled initial velocity because it's 0. And all I got to do was putting square root on both left and right side. Thus, we have VF isolated. Then I substituted all values. Negative and negative cancel each other out. Perfect. Meter and meter, they will square. Second is already square. So once you square root it, you will have just meter per square. So unit analysis worked. Don't forget to round it out to a significant digit. In this case 3. So report it as 30.5 meter per second downward. See you next time, y'all.